So the next problem, we're just going to get a little more practice with doing all this. And what we're going to find is this would be what you would be given. So what if we had y is equal to 5x, and y for the second function is x squared plus 2x plus 2. And the only thing that you're told is that here are two functions that they intersect and they form an enclosed region, and we're revolving that entire enclosed region about the x-axis, and we want to find the volume, you know, of that guy. But we're not giving any limits. We don't know what a and b are integration-wise. So at that point, that's a big clue to you that you need to figure that out yourself. You need to either graph them or solve the system of equations to figure out where they cross. And so that's, you know, pretty common. And so the way to do that is just what we did before. We want to set them equal to each other to figure out where they cross. So if we do that, we'll get 5x is equal to x squared plus 2x plus 2, because we're saying the y values are equal. And so what we'll have is x squared, we'll take the 5x and move it over here, give us negative 3x plus 2, and that's all equal to 0. All I did is take the 5x and move it over here, and it gives us negative 3x. So now we need to see if we can solve this guy for x. So let's go ahead and see. Let's go ahead and save some space and go over here. Let's see if we can factor this guy. We know we're going to have an x here. We know we're going to have an x here. For 2, the only way you can really get it is 1 times 2, so we'll put that there. And since we have a negative 3 in the middle, we'll put minuses in both places so that when you get negative x and negative 2x, they'll add up to give you this. So this is the proper factorization of that, and so whenever you get this, what you found is that x is equal to 1 and x is equal to 2. X is equal to 1 and x is equal to 2. And that means that if you were to plot this, if you were to graph these two equations, they would cross at these values of x. And these are going to basically be your limits of integration. Now you can just go ahead and integrate the thing right now, you know, between these limits and go ahead and plug it all in. But the only thing is you may not be quite sure which function's on top, you know, which function's on bottom. Sometimes it's difficult to figure that out ahead of time without looking at a picture. You can see what happens if you get it backwards. You're just going to get a negative answer. It's not that big of a deal. But it might be nice to know what you're looking at. So let's take a look at a quick graph. So here is x and y. And let's just sort of take a look at what it might look like. So what you have here is a line, and here you have a parabola. So it's not a huge surprise. So what you're going to get is basically the parabola is going to look something like this. Okay, so this is x squared plus 2x plus 2. All right, so let's go ahead and plot this line, y is equal to 5x, and figure out roughly where it's going to be. And if you do that, it's basically going to go and look something like this. It's going to go at a slant like this, something like that. Not quite straight, but that's basically what it's going to look like. Y is equal to 5x, something like that. And you can see the enclosed region between the two graphs is basically right here. And you can see that this intersection point, we're going to call that 1. And this intersection point, we're going to call that 2. Right? I know that the scaling is not exactly right. I didn't do this exactly to scale, but you know, this is somewhere in the positive territory. This is also in the positive territory. This is 1, this is 2. But you can see the idea. The idea is that you have the blue curve is the one on top. When you're integrating from 1 to 2, all you care about is this region in the middle here. And in this region, the blue line is the one that's on top. So when we set our integral up, we want to put that one first. So let's go ahead and do that now and show you what I'm talking about. We want to integrate from 1 to 2, because these are the limits of integration we